Hi, science students. Welcome back to another day of digital learning. Today we're going to focus on reading and analyzing solubility curves. We've done a lot of practice with analyzing graphs throughout the school year. So the only difference in these graphs and ones that we've looked at previously is that we see lots of lines on solubility curve graphs, and they're all telling me about different compounds at different temperatures being dissolved into different solutions. So it looks more complicated than it is, and we're going to take them line by line to make sure we understand how to analyze these graphs. So let's go ahead and get started. You should have copied down the questions from eClass, but if you did not, I would like for you to pause the video right now and write down these 4 questions. So for part 1, we're going to use this graph that you see on the left. And it says how many grams of KClO3 would be needed to dissolve in 100 milliliters of water to make a saturated solution at room temperature. There's a lot of pieces of information here to analyze. So it says that there's going to be 100 milliliters of water. I know that that's going to be true for all of the compounds because it tells me that on this axis of my graph right here, grams of solute per 100 grams of water. So that really is an unnecessary piece of information in the question, and we can say, okay, they're all in 100 milliliters of water, and we can keep moving. So we want to make sure it's a saturated solution. We want to make sure it's at 45 degrees. We want to make sure it's this compound. So first I'm going to find that compound right here, KClO3, and I can see that its curve kind of is right here. So I need to make sure it's saturated, which means I need to be on the line. That line shows the saturation level. Anything above that line would qualify it as supersaturated. Anything marked below that line would qualify it as unsaturated, and we'll get into that in a little bit. So I want to look at this line and I want to see where it lands at 45 degrees temperature. So 45 degrees is here. We're not going to have perfect estimates because we're working with a graph on the computer, but do your best. And when you scroll up at 45 degrees, we're at about 15 grams of KClO3. So I'm going to put that as my answer. Let's change the color so it's easy to see. 15 grams of KClO3. Let's go on to the next question. How many grams of KCl would be needed to dissolve in 100 milliliters of water to make a saturated solution at a temperature of 65 degrees Celsius? So again, I know I'm keeping that consistent amount of water so I can focus on what the compound is and what that temperature is to make sure it's a saturated solution. So I want to go to 65 degrees and I want to trace up to the line. See, it's going to be difficult to trace up perfectly on the computer, but trace up to the line where it says KCl right there. And then I can trace over to see that that's about 45 grams of KCl at 65 degrees. So again, I'm going to type that in. All right. So let's go on to the next question. To what temperature would you have to heat 85 grams of KNO3 in 100 milliliters of water to get it to dissolve completely? So I would need it to be completely saturated so I can find where the line is for KNO3. KNO3 starts way down here at about 15 and goes all the way up to 150. It's got a lot of change as far as increase in temperature, how much it can be saturated. So if I'm looking for 85 grams of KNO, I know that this is temperature across the bottom. That's not going to help me to go up to 85 grams over here. I actually need to go over here on the left side. So I'm going to go up to 80, and I'm going to go in between 80 and 90 and trace over to here. When I arrive here, I'm on my line for KNO3. I can then trace all the way down to right here in between 50 and 60. So that temperature for this one to dissolve 85 grams of KNO3 in this water is going to be 55, let's change the color, 55 degrees C. Let's keep going. Number 4 said, to what temperature would you have to heat 150 grams of NaNO3 to get it to dissolve completely? So I see that line for NaNO3 is right here. It begins at saturation at a little more than 70 and goes all the way up to 150. It says I need to heat 150 grams and get that to dissolve. So I want to start way up here at where 150 is for NaNO3. And then I can trace down to what that temperature is where it's going to dissolve. In between 80 and 90, it's going to be 85 degrees Celsius. Let's make that red to make it easy to see. So far, what you've done in the graph is you've been able to say, okay, this is how many grams would dissolve at this temperature. And you've also been able to say, this is the temperature that I would need to get my solution to in order to dissolve the grams, which is great. That's going to be part of your lesson for the task that you need to complete for today. But the other part of that is going to be able to identify, is it saturated? Is it supersaturated? Is it unsaturated? So we're going to look at the same graph, and we're going to kind of flip it a little bit, and we're going to say, is this saturated, unsaturated, or supersaturated? So let's look at the first one. The first one tells me I have 55 grams of NH3 at 20 degrees. So I want to find the line for NH3 first, and I can see that that one starts at 90 and heads downward towards less than 10. So if NH3 has 55 grams, I'm going to be right here at 55. And I could trace over to my line, and that's going to be at 20 degrees right there. Is it at 55? That's what this question is asking you. Do I have 55 grams dissolved right here at 20 degrees? I'd say because we're eyeballing it, you might potentially think that that is, yes, that's saturated, that's perfect amount. However, we actually have more saturated, this is a super saturated solution right here at my 55 degrees at 20, because when I trace over to here and I land on 20, it's actually above the line for NH3. It's right here. It's very close, but it's above. So this one is actually going to be super saturated. You could put abbreviations if you'd like to. You could put SS, but I'm going to go ahead and type it out. Super saturated. The next one says 10 grams of this long compound, Ce2SO4 at 10 degrees. So I need to find that long compound first, and it starts right here below 20 and goes down to almost 0. I need to go over to 10 degrees and trace up to my line. So I know I'm at 10 degrees here, and it says at 10 grams. So that's right here on this little point. I can see that that is below the line for Ce2SO4, so I know that that's going to be unsaturated. I could add more solute at that point to get up to saturation. So this is actually going to be unsaturated for the second one. The third one says 125 grams of KNO3 at 60 degrees. So I want to go to 60 degrees and trace up until I find KNO3. So at 60 degrees, I would be able to put in 100 grams, but I know that this says 125 grams. So I know that that's more than what can be saturated for KNO3 at 60 degrees. So this is going to be actually super saturated, because if I trace all the way up to 125, it's above the line for KNO3. It's certainly above its saturation level of 100. So this is going to be considered super saturated. All right, the next one, NH4Cl at 80 degrees. So I'm going to go to 80 degrees. I'm going to trace up to NH4Cl, which is right here at about 65. So it says 65 grams at 80 degrees. That's how much can be saturated, because it traces me up directly to the line for this compound. So I'm going to say that this one is saturated. It's at its saturation level, but we have not exceeded the level. Letter E says 12 grams of NH3 at 90 degrees. So I'm going to go over to 90 degrees, and I'm going to trace up to NH3. I've got right here, NH3 at 90 degrees. It's at 10 grams. This says 12 grams, so we know that it's going to be super saturated because 12 is more than 10. And if I have more solute than I have saturation, room for saturation, then I know it's going to be super saturated. All right, letter F says 10 degrees, 80 grams. So I'm going to trace up to 80 grams, 10 degrees, and I'm looking at NaNO3. This is right on the line, so I know it's going to be saturated. At 80 degrees, I'm going to trace up to NaNO3 all the way up here. NaNO3 is right here at about 145. And that's what this says, 145. So I'm going to be right on the line, and this one is going to be saturated. All right, and then our very last one says 100 degrees, 35 grams of NaC. So I'm going to take my cursor and drag it up 100 degrees to 35. That's going to put me about right here, and I can see that NaCl's line is above that. At 100 degrees, NaCl is saturated at about 40 grams. So I know that 35 is less than 40 grams, and I'm going to put that this one is unsaturated. So for today's lesson that you will turn in, you need to be able to identify if something is saturated, unsaturated, or supersaturated based on where its saturation line falls in the solubility curves. You also need to be able to identify what temperatures would be needed to dissolve certain amounts, or at what amount would be needed to dissolve at a certain temperature. That's everything I have for you today for reading and analyzing solubility curves. Have a really good day, stay safe, and I'll see you tomorrow. Bye-bye.